Welcome, students, to this module of e-learning. I, Dr. Maria A. D'Souza, Assistant Professor, St. Xavier's College, would like to present this module to the students of Bachelor of Science First Year, Botany Generic Elective, Semester 1, the paper code BOG 101, and the paper title Environmental Biotechnology. I will be presenting the module number 20, Organic Chlorinated Hydrocarbons, under the unit number 4, unit title Xenobiotic Compounds. The outline of the module will be definition of chlorinated hydrocarbons, examples, characteristics, toxicity, and uses of chlorinated hydrocarbons. Once the student completes this module, you'll be able to describe, cite examples, and explain the characteristics, toxicity, uses, and effects of chlorinated hydrocarbons. Chlorinated hydrocarbons, due to a wide variety and divergent chemical properties, are known by a wide variety of names like organochloride, organochlorine compounds, chlorocarbons. Now, chlorinated hydrocarbons were the first synthesized chemical pesticides that were used, and hence they were widely used as that. And because of that, they are also known by different other names like chlorinated organics, chlorinated insecticides, chlorinated synthetics. To define chlorinated hydrocarbons, they are a heterogeneous group of organic chemical compounds containing chlorine, hydrogen, and carbon atoms only, and with at least one covalently bonded atom of chlorine that has an effect on the chemical behavior of the molecule. Now let us see some examples of chlorinated hydrocarbons. The first ever compound that was synthesized, the chlorinated hydrocarbon that was synthesized, was in Germany. But its insecticidal properties were made known only by Paul Muller many years later. Later, during the World War II, this compound was used, the DDT was used against many insect vector-borne diseases, and it saved millions of lives. DDT, the full form of which is dichloro diphenyl trichloroethane. This is a colorless chemical pesticide with this chemical formula used to eradicate disease-carrying and crop-eating insects. Then we have DDE, dichlorodiphenyl dichloroethylene. This chemical compound is formed by the loss of hydrogen chloride, that is dehydrogenation reaction from DDT. It is known to affect the nervous system, causing excitability, tremors, and seizures. More in these series are like BHC, that is benzene hexachloride. The beta isomer of benzene hexachloride is quite persistent in the environment and is known to be a contaminant in human fat and blood. Whereas the gamma isomer, lindane, is a cumulative poison, affecting the liver and kidneys by causing lesions. And it also affects the central nervous system. It's a potential neurotoxin, much more rapid than DDT in action. Then we have methoxychlor. Methoxychlor is a persistent toxic chemical, and it is known to be metabolized to hydroxyl ethyl derivatives. And it is banned because of its acute toxicity, accumulation, and endocrine disrupting activity. Then we have cyclodines, example aldrine, dieldrine. Now, these cyclic halogenated hydrocarbons, they possess a chlorine-substituted endo-methylene bridge structure. Now, these cyclodines, they undergo epoxidation reaction, resulting in the formation of respective epoxides. And these epoxides are much more toxic than the parent compound. For example, aldrine is metabolized to dieldrine in plants and animals, and dieldrine is more carcinogenic and primary site of action in the central nervous system. Then we have endosulfan. It's a contact and stomach poison, efficiently absorbed across the skin. It induces acute neurotoxicity, potential for bioaccumulation, an endocrine disruptor affecting the hormones. We have endrine, colorless, odorless solid, was used as an insecticide, rodenticide, pesticide, and it can be stored in the body fats and it act as a neurotoxin on the central nervous system. Heptachlor, it's a white tan powder, persistent organic pollutant, and this chemical and its epoxides, they accumulate in the body fat and are more persistent and are more toxic. Then we have chloridane. It's a white solid used as a pesticide and also for termite treatment, but it was banned many years later after its introduction. Why? Because it is metabolized to oxychloridane, which is stored in the fat and excreted in milk of lactating animals. And it's a very potential neurotoxicant. Now, coming to the characteristics of organochlorides or chlorinated hydrocarbons. These are quite volatile compounds and they're quite stable and have a long residual action. They're highly lipid soluble, accumulate with repeated exposure, show a very high affinity for fats concentrated in fatty tissues of animals. Now, there is a major toxicology concern that is DDT and chloridane, because they have so many bad effects, they were banned from commercial use because they persist in the environment and they accumulate in the biological system. Some of them are recognized as water pollutants, and high frequency ultrasound has been applied to eliminate them. Most of them are neurotoxins, known to disrupt and affect the central nervous system, with symptoms of tremor, jerking of eyes, changes in personality, loss of memory. All of them are contact poison, although they penetrate insect cuticles at different rates. And some of them are carcinogenic in nature, causing cancer. Now, like the uses of chlorinated hydrocarbon are many, and they are being used in many places, like organic solvents, frequently used as industrial degreasing agents for the metals, paint strippings, and dry cleaning. They also form the building blocks of other chemical products, such as pharmaceuticals, plastics, and solvents. Chlorinated hydrocarbons were the first ever synthesized pesticides, and hence they are widely used since then in the agricultural field as structural pest and malaria control all over the world. Lindane is used medicinally to treat lice and scabies. These are the references, students. These are the web links. Thank you, students, for a patient hearing.